Welcome back, chemistry class. We're going to discuss the atom now, and the basics of the atom. As we said, an atom is the smallest divisible particle that retains its chemical properties. Now, we say smallest divisible, meaning we can divide it and retains its chemical properties. What we're saying here is that once I get smaller than an atom, so I go down to its subatomic particles, the protons, neutrons, and the electrons, once I get smaller than that, I lose the chemical properties of that atom. So I lose what it is that atom can do with other atoms. So let's say chlorine and hydrogen, they can readily bond. Well, the reason why is because they're a combination of protons, electrons, and neutrons. Same with hydrogens, protons, electrons, and neutrons. What makes the properties of hydrogen specific to hydrogen, and what makes the properties of chlorine specific to chlorine, is their own relative numbers of protons, electrons, and neutrons. Once I get smaller than that, I lose what it means to make an atom with its chemical properties. So I can't bond a proton to a neutron or something and get a chemical reaction. That's not what those are nuclear reactions whenever I break them up and separate those down. So again, for our sake, protons, neutrons, and electrons are extremely important. Now, let's discuss what that means to when we're talking about an atom, what we want to know. When we're discussing the properties of an atom, what we're really discussing are maybe three important ideas. We're going to discuss the identity of the atom. We're going to discuss the charge of the atom. And then we're going to discuss the mass of the atom. Those properties, those three things that we care about: the identity, the charge, and the mass of an atom, and what role they have. In order to understand these three terms of the atom, the identity, the charge, and the mass, we're going to have to understand this relationship between the subatomic particles, the protons, the neutrons, and the electrons. So to get a better view of that, we need to understand what those different parts of the protons and neutrons and electrons have and what role they play on each other. So if we come to this chart, let's look at protons, neutrons, and electrons. And I want us to notice something specific. These protons, neutrons, and electrons, or protons, electrons, and neutrons, have their own specific properties. And what you need to know beyond anything else is that protons are the most important one. Protons help determine the charge. So I'm going to the right. Protons help determine identity. They are the only ones that determine identity, okay? The atomic number and the number of protons are the exact same thing. So number of protons equals atomic number. Nothing else does. It doesn't ever matter. So if we look at our periodic table of elements and we see that something has 17 protons, well, I know that's going to be chlorine. Just look at it. I know for a fact. Do I care if it has 20 neutrons and 18 electrons? I don't care. Let's do another example real quick for identity's sake. Say something has, let's give it 38 protons. 38 protons. Let's give it 55 electrons. 55 neutrons. 55 neutrons. And let's give it 36 electrons. And I want to know only the identity. I want to know specifically the identity. Well, which one do I care about? I only care about the proton number. And so so the identity of that is going to be strontium, because I look at my periodic table of elements and I go, oh, strontium is 38 protons, so it's going to be strontium, Sr. I got my identity, check. The next thing I care about is charge. I want to find the charge of something. So what do I use? Well, I use protons also. Again, I'm going to have to use protons. But I don't use protons alone. I have to use something else. And charge is going to be, which one would I use? Since I know I'm going to be using protons, which other ones will I use? Well, let's look over here. I see that protons have a +1 charge, so I'm going to use that. But then I have electrons with a -1, and then I have neutrons with a 0. Which one will not have an impact on charge? Specifically speaking, neutrons will have no impact on charge. It doesn't matter if I have 1,000 of them or I have 0 of them. It won't matter, because they will neither add to or take away from they'll neither add to or take away to charge. So I don't care about neutrons when it comes to charge. I only care about protons and electrons. And we see that a proton and electron have differing charges. So let's come over back to this atom over here. What's the charge going to be? Well, I have 38 positives, and I have 36 negatives. How do I know that? Well, back at this chart, protons are positive, P for positive, and electrons are negative. So if I have 36 electrons, that's 36 negatives, and if I have 38 protons, that's 38 positives. Do I have more positives or do I have more negatives? I have more positives. So by how much more? I have 2 more positives. So that means my overall charge is going to be positive 2. Another way to look at this is, let's do charge is going to equal to, we could say my charge is going to equal to my protons minus electrons, the number of electrons. So that's going to be 38 minus 36, which is going to equal plus 2. Okay? And you can reverse that. If I have a plus 2 charge and it's strontium, how many electrons will I have? Well, 38 minus what number is going to get me positive 2? Well, that would be 36. So I hope that helps you on that one. The last thing that we care about is going to be the mass. And which one's important for mass? Let's do a different color here. Which one is going to be important for mass? And let's look at... So let's go back up to this chart over here. I am going to have 38... let's look at this mass over here. Look at these numbers, 10 to the negative 24 and 10 to the negative 24 over here. Those are extremely tiny numbers, and then when I'm trying to find the mass, I don't want to keep adding those up every single time. So I come over and I give it a relative mass of 1. Since these are roughly the same, let's call it both the same mass of 1. But let's look over here. This is negative 28. That's 4 decimal places smaller than this one. And so it's almost roughly a difference of 1,836. So I would need 1,836 electrons for every one of these 2. So do they ever matter? No, they absolutely don't. The most electrons an atom can have is 118 electrons. So if I need 1,836 to equal that, what good will that do? It won't do any good. So for example, I have 38 protons and 55 neutrons and 36 electrons. I would need roughly 36 electrons. Let's go do the math real quick. I would need 36 times 1836 electrons, so 66,096 electrons. I would need 66,000 of those to make a dent, to add the impact that these protons or neutrons. So do I care about electrons when it comes to mass? I don't care, don't care, don't care. So I only care about 2 things when it comes to mass. I care about protons and I care about neutrons. I do not care about electrons when it comes to mass. And the mass of the atom is all in the center, and that's going to be so mass is going to equal protons plus neutrons. So what's this mass going to be? Well, if I have 38 protons and 55 neutrons, what's that mass going to be? Well, when I add those together, it's going to get me 83 or so. It's going to give me 83 AMUs. That's my mass. So what does this mean? If you look at these right here, I have this atom that I'm looking at has a different number of protons, it has a different number of neutrons, and it has a different number of electrons. What does all this mean? In school, you probably remember that you could just say, oh, it's number of protons, neutrons, and electrons are all going to be equal to each other. That is not the case. That is not the case in nature. So I want you to focus on this part right here. 2 terms you need to know. You need to know that all atoms are not going to have the same number of protons, neutrons, and electrons. Very rarely will they ever have the same number of protons and neutrons. Very rarely. As a matter of fact, any time in nature that an atom loses or gains neutrons, it's going to be an isotope. So in nature, almost every atom are really going to be isotopes. So anytime there are 2 atoms that exist that have a different number of neutrons, those 2 things are isotopes of each other. So protons and neutrons, when I can never change my number of protons. That needs to be more clear than anything else. You can never increase or decrease the number of protons without changing the identity of the atom. It is tied directly to the identity of the number of protons. But I can increase my number of neutrons. So whenever an atom I have two atoms that have a different number of neutrons from each other, that's going to be an isotope. Now, an ion is whenever you have a different number of electrons than protons. So I can change these two and get something called an ion. I can either be a positive ion or a negative ion. I can either gain or lose electrons. Remember, I can't gain or lose protons without changing the identity, but I can gain or lose electrons. Whenever that electron number changes, then you get a new charge, or you get something called an ion. So let's recap real quick. An atom consists of protons, neutrons, and electrons. Protons are the most important. They are the atomic number, and I can't change that. Protons and neutrons, protons help determine identity, or they determine identity, they determine mass, and then they determine charge. Neutrons are in the nucleus with protons, and they only determine the mass. Electrons are outside of the nucleus by themselves, and they help determine charge. So, in order to determine the identity, all you need is the number of protons. If you don't know the number of protons, but you have the identity, therefore you have the number of protons. It's really easy. If you need to determine mass, you need the number of protons and neutrons. If you're trying to determine charge, you need the number of protons and electrons. If you have mass and you have protons, then you can find neutrons. So, example, if I have a mass of 40 AMUs and I have 18 protons, well, what's going to be my mass? Well, mass equals protons plus neutrons. Well, 18 plus what will give me 40? And that's going to be 22 neutrons. So if I have so therefore I can really easily find my neutron number also. Let's go to charge over here. I need protons and electrons to determine charge. So say something has a charge of -3 and it has 15 protons. Well, I know that my charge is equal to protons minus electrons. Or let's say charge equals protons minus electrons. How many electrons must I have to have gone to make my atom -3? I must have 3 more negatives than positives. So that's going to, or another way to look at it, 15 minus what will give me -3, and that's going to be 18. So 18 electrons. That's how we do that. So, and if I have a different number of, if my electron number changes, I get an ion. If my neutron number changes, I get an isotope. I hope that clears anything up. Thank you.